on Earth. More and more space debris is being discovered by people. Some recovered debris from crashed rocket bodies and spacecraft has been transported to research centers over the years for close examination. This space debris is being examined closely to help with study into the fiery and destructive re-entry process. For instance, scientists are advancing design options that would cause arriving space technology to disintegrate more completely during its fall through Earth's atmosphere. Find out more about this rising problem in today's video. Jigsaw parts. Marlon Sorge, a technical fellow with the Aerospace Corporation's Space Innovation Directorate and the Center's Executive Director for Orbital and Reentry Debris Studies, claimed that when you get those fragments back, there's absolutely some intriguing information. According to Sorge, understanding the reentry process is very much like trying to put jigsaw pieces together, but you don't have most of the puzzle pieces. Researchers may be able to gain a better understanding of the circumstances that arriving hardware encounters during its rapid ascent through Earth's atmosphere, thanks to the ongoing work. Sorge remarked that, in some circumstances, knowing how the gear appeared before introduction is a major bonus. Researchers can recreate what happened in the trajectory of gear falling from orbit by including the location of the trash. Getting through the dive. How did the pieces of space trash survive the sudden dive? What kind of processes are taking on inside a piece of trash as it travels to Earth while being heated at great speed? Concerning design for extinction, there are undoubtedly some things that should never be done, according to Sorge. We have many spherical titanium containers that were left behind by space debris. They appear to have just been placed on the ground, save from the fact that they are a touch soiled. The message is clear, Sorge continued. Don't use materials that are going to survive. T.S. Kelso, the webmaster for Celestrak, an online tool to help with understanding of the orbital environment and how to use space safely and responsibly, agreed that learning from retrieved space rubbish is a bonus. The investigation, according to Kelso, seems very worthwhile to investigate how what we believe would reach the ground actually lines up with what actually happens. Building rockets and spacecraft that present less risk to things near or on the Earth's surface would be possible with the aid of picking up the fragments of re-entered objects, according to Kelso. Community awareness. Darren McKnight, a senior technical fellow at Leo Labs, a business that has developed radars globally to provide distinctive measurements and data products that improve space safety in low Earth orbit, also adds his voice to the diagnosis of impending debris. More people need to be made aware of the expanding debris problem, according to McKnight. What goes up must come down eventually, according to McKnight, and when it does, it frequently accelerates to lessen the possibility of an orbital collision, which puts aviation and people on the ground at risk for fatal collisions. According to McKnight, active debris removal, or ADR, is crucially necessary in Earth orbit, but it is not the best option for every significant piece of trash that is up there. The good news is that while orbital risk continues indefinitely, aircraft and ground risks are one and done. Knowing when ADR via controlled re-entry is required and when it is not is crucial because it is more expensive than uncontrolled re-entry, he explained. Flow of heat. École Polytechnique Fédérale de Lausanne researcher Alexandra Luton has also been investigating the orbital debris issue. Luton points out that a number of variables must be understood by scholars in order to completely comprehend the circumstances under which someone can discover space waste on Earth. These variables include, among others, the object's initial mass, the type of insulation protection it has, its orbital velocity, the angle of re-entry flight path, and the breakdown order. The carbon fiber reinforced plastic or CFRP wrapper typically remained firmly connected in all of these situations, even if the majority of the matrix component has been pyrolyzed, according to Luton. Pyrolysis is the term used to describe the thermodecomposition of materials. According to Luton, only the top carbon fiber layers of approaching space debris often experience delamination and spallation. a process in which material is released from a body as a result of collision or stress. According to Luton, this clearly suggests that the matrix absorbs or deflects the majority of the incoming heat flux of the destructive reentry, and these layer degradation processes operate as an ablative heat shield. Therefore, he continued, the community has discovered the key behaviors and major material characteristics that affect such processes after multiple research on CFRP thermo-ablative processes via plasma wind tunnel test campaigns and more particular material testing. In order to develop and improve particular composite material demise models for re-entry casualty risk assessment, these factors are now utilized. By choosing a particular material combinations that should permit a full and quick separation and demise of a spacecraft's exterior panel upon re-entry, Luton is attempting to make composite structure termination. Demand for action. Leading space organizations have been urged by an international open letter to lower the risks associated with uncontrolled re-entries of rocket bodies and other space debris. The Outer Space Institute, or OSI, issued a demand for multilateral negotiations on a controlled re-entry accord around the end of last year. At the University of British Columbia in Vancouver, OSI is headquartered. Uncontrolled spacecraft re-entry poses a significant, cumulative, and quickly expanding risk to people worldwide. Concern over uncontrolled rocket bodies is particularly important, according to the letter, which was delivered to the heads of space agencies everywhere. We request that your organizations begin multilateral tasks on a controlled re-entry agreement, starting with rocket bodies in collaboration with the foreign ministries of your states. We further urge each of your states to voluntarily commit to a national regulated re-entry regime, acknowledging that such negotiations take time. The letter emphasizes the hazards of casualties from uncontrolled rocket body re-entries, but also raises the issue of uncontrolled satellite re-entries, which it says may eventually dominate the casualty risk should tens of thousands of medium to large satellites be deployed into orbit. To lower all uncontrolled re-entry risks, the OSI Open Letter offers a re-entry regime that initially targets rocket bodies before expanding to satellites. It is untenable to merely hope that unchecked re-entries won't be harmful. These avoidable and thus unneeded risks can be significantly reduced with strong leadership, collaboration, and international goodwill. Planning ahead is necessary. Concerning re-entering objects, Sorge of the Aerospace Corporation believes that policy creation and risk assessment are ongoing tasks. We're making an effort to catch up and try to understand what it all means and what we should be doing to prevent things from getting worse, said Sorge. Sorge believes that it is essential for the space community to consider debris in advance. Because there wasn't as much traffic back then, we had a little more grace. But as time goes on, it won't necessarily be the case, explained Sorge. The effects of the debris need to be considered in advance, not after the fact. What do you think? Are we doing enough to find solutions for this problem? Comment your thoughts below. Thank you so much for watching the video. Don't miss out on our latest uploads. If you wish to stay up to date with the latest space updates and discoveries, hit the subscribe button, like the video, and turn on all notifications to see more of our latest videos in the future.